Hello everyone, this is exam physics. Why does adding a resistor sometimes increase but sometimes decrease the overall resistance? If we connect resistors in series, then the current flowing through them is the same. So the PD across R1 is V1 equals to IR1. The PD across R2 is V2 equals to IR2, all the way until the PD across Rn is Vn equals to IRn. All these voltages, of course, add up to the total PD across the entire resistor network. So V is equals to V1 plus V2 plus all the way until Vn, which we can write as IR1 plus IR2 all the way until IRn. Let's move I to the left side of the equation. Now V over I is obviously the effective resistance of the entire resistor network. So the effective resistance is simply the summation of the individual resistances. Basically, for resistors in series, to maintain the same current, every time you add a resistor, you incur additional PDs. So the V in the V to I ratio increases, and that's why adding a resistor in series always increases the overall resistance. When you have resistors in parallel, then it's a different story. Resistors in parallel will have the same potential difference across all of them, right? Same potential difference. So the currents through R1 is V over R1, the currents through R2 is V over R2, and the currents through the nth resistor is V over Rn. And all these currents sum up to I, the currents flowing through the resistor network. So I is I1 plus I2 all the way until In, which we can write as V over R1 plus V over R2 plus all the way until V over Rn. Move the V to the left side of the equation, and we have I over V equals to 1 over R1 plus 1 over R2 plus all the way until 1 over Rn. Now listen, V over I is the effective resistance of this resistor network. So I over V will be 1 over the effective resistance of all these resistors in parallel. Now 1 over R actually has a name, no? R is the resistance. So the reciprocal of R is called the conductance. So if we add up the conductance provided by each resistor, we get the effective conductance of this resistor network. Basically, when we have resistors in parallel, then for the same PD across, whenever you add one more resistor, you are allowing more current to pass through the resistor network. The I in the V to I ratio increases. That's why the effective resistance decreases. Another view is whenever you add a resistor, you actually add conductance to the overall circuit. This makes the resistor network more conductive and therefore decreases the resistance. Okay, so now you know when we add a resistor in series, it increases the resistance, but when we add a resistor in parallel, it decreases the overall resistance. Easy, right? Okay, ta-ta!